वो आमतौर पर विनम्र हो ही जाता है।
Hello. Hi. Am I audible? Is my video visible? Can somebody confirm?
Yes, ma'am.
Okay, great. So, good evening, everybody, and welcome to today's tutorial on urban utilities planning, water supply, sanitation, and drainage. So, I think we have two new faces today, like who has not been there before. So, yeah, so welcome all of you to today's tutorial session. So, just to introduce, I'm Jeslu. I'm a research scholar at IIT Kharagpur, a Prime Minister's Research Fellow. I've been working with Professor Pandit for the past 4 years. So I'll be handling all the live tutorial sessions. So let's get started. So today we will be discussing about the content which we which we learned in week 7. Some questions regarding those content. We'll be discussing previous year assignment questions based on week 7. So let's quickly look at the topics which we covered in week 7. So in week 7 this course is about water supply, sanitation, and drainage. So all the previous week till week 6, we have finished the water supply part, and now we will be looking at sanitation part. So this from week 7, we are starting with sanitation and basics of sewage, and in the upcoming lectures also we'll see something more. So we lecture 31 and 32, we saw the basics of sanitation. How do we separate, or what is sanitation, what is wastewater, how do we separate it, all those, and then we saw the sewage systems, how do we lay, and finally in lecture 35 we even saw the types of sewage systems, centralized, decentralized. So all the details we have seen in week 7. So there are not a lot of problems or numericals to be solved for this week. It's mainly theory part and mainly the things which we have discussed in lectures only. So we can quickly go through different questions and discuss. If you have any doubts, we'll discuss that. So since there are a few new faces, let me tell you how we usually proceed with the discussion. So we discuss question by question. So I have around 12 to 13 questions to discuss. And after each question, we'll have a small window where you can ask any question regarding that particular question. And towards the end, after we finish the entire session, we'll have a 5 to 10 minute discussion on any doubts that you have on the questions that we discussed, any previous week's assignment, any question we can discuss in that last 10-minute break. Or we might have more time mostly today. So this is a 2 hour session. So considering that we have less numericals, maybe we might finish a bit early also. And yeah, so any point if my video or audio is stuck, please free to let me know. Like you can put it in the chat box or you can interrupt me because I might not know, I might be just speaking. So yeah, so let's get started. So let's go to question 1. So question 1, match the following and mark the option for the correct match. So we have different terms regarding the sewage types and their definition. So we have fresh sewage, combined sewage, sanitary sewage, and septic sewage on the left hand side, and the definition of those on the right hand side. So let's go this one, first one, A, fresh sewage. Can somebody say which one matches better?
Option A, ma'am.
That's Yeah. So fresh sewage. Oh, you're given the answer itself, option A. That is okay. Let's before we go into that, let's see option by option. That is like this one, fresh sewage. What is the answer for that? I think
Sewage recently originated.
recently, or yeah, fresh. So it is fresh. So it has been recently originated. Correct. Combined sewage.
Combination of
Four
sewage and
months.
stormwater.
Yeah, so that we learned before, like if we can have different types of sewage in the lecture itself, we learned different types of, so it can be only for uh, carrying storm water, or it can be combined, which carries like when we learned about the pipes also, at that time also we learned. So if it's combined, it means stormwater and sewage are together. And you can also have partially combined, which means we will come to that. Partially combined sewage, that is also there. So yeah, so combined sewage is combination of sewage and stormwater. Very good. Now sanitary sewage. So we only have two more options. So anybody, sanitary sewage?
Residential discharge from latrines and urinals.
Residential discharge. Sanitary sewage is residential discharge from laterals and urinals. Okay. And okay, so let's say that. And so septic sewage will be sewage undergoing treatment. Right. That's the option. So Is that option A? Sewage recently originated. Yes, B is 4, C is 1. Yeah, correct. So option A is what you're saying. Yeah, so this is correct. So these are the terms which we learned in our lecture itself. Directly, it is there in one of the slides. We have seen that. So let's see that slide. Yeah, so this is the basic that we learned. So we can have dry refuse or wet refuse. So dry means we have it's garbage, and wet refuse means includes discharge from latrines, urinals, bathroom. So all that is what we are discussing. So that to carry all this wet refuse, all these different sewage methods we use. So we have the sewage, which is liquid waste from the community, and we have combined sewage, which is sewage and stormwater. So just to brush up, so what is the difference between sewage and stormwater? What is stormwater? Hello, anybody? What is stormwater?
Stormwater is from the rainwater discharge runoff.
Yes, correct. Stormwater is rainwater discharge or runoff that we carry it out into underground. So you use pipes in order to carry the stormwater. So yes, so that is and combined sewage means you'll just have one pipe or one path by which it's carried on. So it's a combination of sewage and stormwater. So that combination of that where it's going through the pipe, it's called combined sewage. And then you have sanitary sewage, yes, as rightly said, residential discharge from latrines and urinals. This is also known as black water. So it's sometimes wastewater treatment. In that, we usually separate black water and sorry, I went to the next question. Come, let me go back. Yeah. Okay, I think there's some trouble today. Yeah, correct. So yeah, so this is so we usually separate black water and gray water. The treatment processes which are used for black water and gray water are different. So all this residential discharge from only laterals and urinals is black water, and then when you have bathrooms and kitchens, it's gray water, which means the treatment that we need to undertake for bathrooms and kitchens is lesser than laterals and urinals, right? So that's why this is gray water. Then this is what we discussed. So fresh sewage is which is recently originated. Then you have something called raw sewage, which means it's not been treated. And then we had an option for septic sewage, which means something which is undergoing treatment. And after it is underground treatment, then it becomes stale. It becomes stale sewage. So all these are terms which we normally use. Fine. So any doubts in this question? Shall we go to the next question?
Yes, ma'am.
Okay, thank you. Yes, so question 2. Which of the following parameters constitute the concept of totally sanitized cities? So there can be multiple right answers. So option A, open defecation free. B, municipal sewage and stormwater drainage. C, recycling and reuse of treated sewage for non-potable applications. D, improved public health outcomes and environmental standards. Okay, so let's go option by option. Is totally sanitized city, is open defecation free part of totally sanitized city?
True.
True, yes, open defecation free is true. What do we mean by open defecation free again? We learned about protocols like ODF protocols, that is open defecation free protocol. So there's ODF, ODF plus, then plus plus. So all this mainly talks about keeping our surroundings clean. That is, people should not be seen defecating publicly or outside on the streets. And also from the residences in ODF plus plus protocol, we have methods of collecting this and then transporting it to a different location, and then or you have methods of laying down the drainage channels by which these are removed off. So that's what is totally sanitized cities, where you don't find anybody defecating openly. So yeah, so it is part of totally sanitized cities. Then B, municipal sewage and stormwater drainage. Are they part of totally sanitized cities?
Yes, ma'am.
Yes,
Yes,
very
ma'am.
good. Correct. Yeah, municipal. So you need, so this again comes under this open defecation free concept where you have the municipal sewage system, and you also have stormwater drainage to carry your rainwater, stormwater to the surface water. It can be to a nearby river body or lake, or you can even have underground channels to restore groundwater. So yeah, so you need stormwater drainage also. Then option C, recycling and reuse of treated sewage for non-potable applications. Is it part?
Yeah, it's also true.
It's also true, yes. So, yes, so this is important because again, this also comes under this treated sewage. So, whatever treated sewage we have, so totally sanitized cities means we need it, it is kind of ideal, right? So, you have it's totally sanitized. So, you need to treat your sewage also for this. How much percentage of this has been put into practice, or which are the cities which fall into totally sanitized cities? That's a next level of evaluation. But to conceptually, totally sanitized cities will need to have provision for recycling and reuse of sewage for non-potable applications. By non-potable applications, we mean for irrigation facilities, for industries, or any other non-potable, again for non last class we discussed potable water, wholesome water, and palatable water. So wholesome water is something which is free from any harmful bacteria or disease causing bacteria, but potable water, again, it has the uh, so by non-potable, it can be a wholesome water. If it is potable, then that means it will have the required odor and taste also, which makes it good for drinking purpose. And palatable water is what we usually use for drinking purpose, which is a combination of both wholesome water and potable water. So this we discussed in our last class. So here mainly non-potable water, we are talking about wholesome water applications. And yes, option D, improve public health outcomes and environmental standards.
Yes, ma'am.
Yes, that's also
Yes.
part of it. So yeah, so this is again the importance of improved public health outcomes we have already discussed in the lecture, so I'm not going into the details. But the idea is that yeah, so totally sanitized cities will have all the four components, and there are many other components. So here four options were given, so all the four are needed in totally sanitized cities. Okay, very good. So let's go. So yeah, so this is what we discussed in our lecture. So it should be open defecation free. The apart from the other things which we discussed, so there should be no manual scavenging, and also so by manual scavenging we mean in our sewage sanitation. In the first lecture we might have seen that in the early times we had conservation systems where uh, even human excreta used to be carried manually, or it used to be stored and then it used to be transported to a location. So those later we realized the health hazards associated with these. So we have all the drainage facilities right now. So yes, so totally sanitized cities will also have this provision that we will have no manual scavenging, or manual uh, scavenging will not be there. And for all the sanitized sanitation workers, there will be safety equipment also, so that they do not uh, catch diseases easily. And also for other, if they're going under the drain, or some underground channels, then you need proper safety equipment to protect them from any any hazards happening inside that. Then also the other factors, yeah, so this we saw municipal and sewage stormwater drainage. This was there in one of the options. Recycling and reuse of treated sewage was there in the options. Solid waste management is also part of totally sanitized cities. Services to poor, improved public health outcomes, this we already saw. So these are the concepts of totally sanitized cities. So all these should be met. So yes, so the answer is all the four options are correct. Any doubts in this? Can we proceed to the next question? Yes, thank you. Thank you for that. So this interaction helps. So I can be sure that we can proceed on to the next question. So yes, so question three, match the following acts with its function. So we have around four acts given over here, and the different functions. So let's go act by act. So the first one is Water Prevention and Control of Pollution Act and its amendments of 1974. So which do you think it matches best? You can attempt, anybody.
Prevent and control water pollution and ensure the wholesomeness of water, ma'am. Is it right, ma'am?
Prevent and control. Okay, so you're
Yes, ma'am.
saying, so you feel that this might be the correct answer. Prevent and control water pollution, but you're not sure of the second. Oh, sorry, I think I just went to the answer. Sorry, yeah, you're not sure of the second part, that ensure wholesomeness of water. Okay, let it be. Anybody? Any other difference of opinion? Any other option? No. So I think one easy method to go for match the following in your test also, if you are a bit confused, just to look at the other options. So if you feel that any other option is a better match, then we need to think something more. So in this, I understand you have partially you are doubting whether this part is correct or not. But if you look other options, none of them would be matching this. So it is prevention. So it's clearly given prevention and control of pollution. The other one, the first, this one talks about quality of water. This one talks about environmental improvement. Then here it talks about taxes. So there is, if you go option by option also, we see that there is nothing which mainly looks at prevention of water pollution. So even if you're not really sure of this, maybe we can say that this is the best option which is available over here. So we can mark that. But this would have been a problem if it was and mark the incorrect or correct answer, or point out the incorrect option. So in that case, if you're not sure of the second part, then will not be able to mark it. So yeah, so here match the following, it's okay, but the other portions it might be a problem. But here, yes, so Water Prevention and Control Act, yes, it ensures the wholesomeness of water also. So what do we mean by wholesomeness? I just explained. Can somebody just give a recap on that? Wholesomeness of water. Anybody? Partha should be able to explain. He was there in the last class. So,
Yes, ma'am. Like it can be used for everything.
no, it's no. Okay, okay. I think you're getting confused with the term wholesome. Yes, somebody else.
With
Yes,
palatable and
The
saltable.
waste from water, no?
sorry.
Removal of waste from water.
Exactly, removal of waste from water, or leave alone waste. The idea is that the water does not contain any disease causing or harmful bacteria inside it. So it does not have any dirt or disease causing pathogens, not bacteria. It can be any disease causing elements. It need not be bacteria itself. Without, if the water does not have any disease causing pathogens and it's free from visible dirt, then it's called wholesome. So yeah, we do not take the literal meaning of wholesome, or as Partha said, yes, we might easily misunderstand it to be that you can use it for multiple purposes. No, but here we are talking about, it's a technical term. Wholesome water is water which does not have any disease causing pathogens and or any visible dirt inside it. So this is what I was explaining in the previous question also. So just to give a recap to the students who were not there in the previous class, last week's class. So we have got three types of water. So we have wholesome water, and then we have potable water, and combining this both, we have palatable water. So wholesome water has no disease causing bacteria, but we cannot, or pathogen. I'm not writing the whole thing, I'm just writing half of it. Yeah. So it does not have any pathogens in it, but we cannot use it for drinking. So we cannot use it for drinking purposes, or basically we say human consumption. It's not suitable for human consumption, but for other industrial related uses or irrigation facilities, we can use it. Provided, again, it should irrigation also, we need to see whether there are other chemicals which will harm the soil, so some other factors also we will consider. But the idea is wholesome water can be used, or it's treated water. But potable water will be good in taste. This is what I was explaining a minute ago, but I'm just explaining it again because nobody responded. So taste, odor, all these are good enough, and it's fit for consumption. Now palatable water is both, which has no disease causing pathogens and is also potable in nature. So this is what we actually use. So this is what we say it is fit for human consumption. So there is a standard also, ISO standard, which we use in order to find what is the minimum amount of each component, like nitrogen, all, because water contains different amount of dissolved minerals in it. So what is the minimum amount of these components, or a range which is a minimum and maximum amount which can be there, so that it is fit for human consumption. So ISO standards get that value also. So yes, sorry, I digressed a bit from the question because we were stuck over here saying that the Act, Water Prevention and Control Act of 1971, it prevents and control water pollution, and it will ensure the wholesomeness of water, again, which means that there is no dirt or disease causing pathogens in the water. Yes. So going to option B, Water Prevention and Control of Pollution. Again, the same thing. This is an amendment to that in 2023, the CES Act of that. So which one will this be?
Fourth.
Fourth, very good. Yes, so that's a bit straightforward because it's there. Levy and collection of cess is what is given in option four. So why do we need cess or taxes on water? Why do you think it's important? Why do you think this act came into being in 2003? Anything, your observations, what do you feel?
Recover the cost of infrastructural development and also efficient use of water.
Very good, very good. Yeah. Yes, correct. Those are the two exact points. So, first one is that sometimes we need some investment. So, that is a general reason why you take taxes for any water supply system. So, that is there for all residential, industrial, everywhere you have a certain amount of cess which is there. But this act or the cess act in 2003 mainly focused on industries also. Why? Because of the second reason why you need efficient use of water. So in our initial lectures in the week one and week two, we discussed about why we still, especially in India, why uh, we are facing groundwater depletion and we are facing water crisis, even though there is adequate amount of rainfall or there's adequate amount of water. It's mainly because water is not being used properly or there's misuse of water. And one of the main factors for this misuse was that of was because there's no record of the wells or there is there are no specific rules which prevents people from using water. There are certain rules, but there are that we discussed also in week two. We discussed what are the rules which are in place. I also sent you some documents, some government notifications which you can go through. So all these are there, but the problem is when while implementing it, there is some gap between implementation and the rules which are there. So this cess act came up in order to curb this issue of people misusing water or overutilizing water, especially industry. So you have different you're paying for it. But again, the problem with this is that sometimes it's not accounted. So there's unaccounted use of water. So again, so that's the gap again. So there's a rule, but then it's people are misusing it in a way that they're not registering the water use that they're doing. So we need more rules in order to curb that or more implementation or monitoring mechanisms in order to solve this. So that's one reality problem that we are facing. So yes, so let's go to option C, which is the Environmental Protection Act. So which one does that match to?
2.
Second.
Yeah, protection and improvement of environment. So these are very direct right now. So I'm not going into the details. Now, option D, designated best use by CPCD in 1981. So yeah, so that's the first one. So we have already said that. So why best use? Because the water is put to use that for the demands that requires the highest quality of water and it's designed designated accordingly. So this again, in order to so you have different levels of water, right? So you have this wholesome water, potable water, palatable water. Similarly, once you treat the water again, you have certain based on certain amount of impurities which is there. You can grade the quality of water, which is high quality, which is not so high quality, which is low quality. Then you have the fine, like the sludge when it comes, which is really bad quality. So based on the quality of water, you're designated. So this act, what it mainly says is that it designates the water for the best use. For instance, if it's palatable water, then you're giving it for drinking purposes. Whereas if it's wholesome water, you're giving it to industry. So like that, you're designating it so that uh, you're using all the water that you have. And it's very straightforward. Okay, so any doubts in this question? No, shall we
No.
proceed? Okay, thank you. Let's proceed further. Yeah, so this is what we saw in the lecture also. I'm not going into the details, so I just wanted to show that this is from this slide only all these questions have been taken. I think I've already explained it. So yeah, so this is yeah, so option A will be the answer for that. So yes, so let's go to question 4. Open defecation free cities involve access to safe sanitation and waste dash facilities for households. Disposal, collection, management, treatment. This is a bit tricky question. So can anybody attempt this question? Yes, you can attempt. We can discuss after that.
Mostly disposal.
Okay, so you're saying disposal. Open defecation free cities involve access to safe sanitation and waste disposal facilities. Okay, fine. Anybody, any difference of opinion? Anything else? You feel connection, management, and treatment. Okay, so disposal is good. That's a good answer. Why can it not be collection? Or does open defecation free says that it does not why can't it be open defecation free cities involve access to safe sanitation and waste collection facilities for household?
For disposal, anyway, you have to collect it from. So after that, you have to treat it. For that, you have to do management. So it disposal covers everything.
Oh, okay. So you're saying if at the user end, if you provide some facility, then it will be covered. So like that, you said disposal. Fine. Okay.
Yes, ma'am.
Fine. Anybody else? Any other opinion on that? Difference of opinion? Or everybody says disposal? Okay, so disposal is the correct answer. Yes, for open defecation free cities, in this particular question which is there, there should be access to safe sanitation and waste disposal facilities for households. But the logic which Partha said is not the way by which we arrive at this answer. It's not that at the residential level, if we give a disposal facility, everything else will fall in place. It will not, because if you have a facility for disposal, but if you do not manage it properly and if you do not treat it properly, then it creates a problem. So, for instance, you might have seen. So I have seen this in Kolkata very. So there's right outside the airport if you're going, there's a huge. I think it's a. I don't know how much area is there, but it's very huge. All the waste which has been collected, it's dumped over there. It's a bio. It's supposed to be incinerated, so it's dumped over there, waiting for its turn to be incinerated, but it's not. So you pass through that locality. It's completely in a very you cannot go through that road. It's right outside the airport. So anybody crossing the airport and going to the city will have to see that at least once. I'm sure if anybody has been to Kolkata, you might have seen. I've observed this in many other cities also, not just in Kolkata. In Tiruchirappalli also, I've observed that there is a huge waste pile dump because of dumping a huge pile has been formed. So the problems with this is that there is collection. So that's because they have a disposal facility. They have somebody's and they are keeping it somewhere. Somebody is even collecting it. So which means the second step is also done. But what happens? Maybe management side, some weaknesses are happening, and treatment side, definitely a weakness is there, or it's not being planned properly. So just by having this facility, our city, it's not necessary that all the others will fall into place. So why open for this question only disposal is the answer is because we are talking about open defecation free cities, which means we're only talking about ODF. So we learned in our lecture there is ODF, there is ODF, then there's ODF plus, and then there's ODF plus plus. So we start with ODF. So ODF basically means that we should not, like, nobody should be publicly seen defecating, or people should be, or the sanitary facilities should be good enough that people should be, there should be some provision for people to dispose their waste. So this is only the first step where we are providing them a facility to dispose. But if you're going to ODF plus, then it will come, collection will come into that. And when you go into ODF plus plus, you will have the management and treatment facility. So this, your totally sanitized cities, or the next what we discussed before, that comes in this ODF plus plus, where you have all the collection, management, treatment facilities. But since the question asks for only open defecation free or only ODF protocol, we are talking about disposal only. But again, to repeat, it's not because if you take care of one, the others will fall into place. It will not fall into place. You need to separately take care of everything. But you can say that if you're taking care of the treatment, if you're saying that I'll have management and treatment, then probably disposal and collection will be included in management, because that is part of management. But just because disposal is there, all the others will not fall into place. Right. So let's see. This is what we saw in the lecture. Sorry, slide's not loading. 1 minute. Yeah. So this is what we saw in the lecture. So ODF, it means open defecation free. So this is what was asked in the question also. So we have 3 levels of protocols: first, second, and third. In the first one, it just said that no person is found defecating in open during any time. So that means it should be 100% coverage should be applied. And ODF plus plus means not a single person is found defecating during any time, and all community and public toilets are functional and well maintained. So here again, so we have the community and public toilets coming into play over here. And now ODF plus plus, we have all the septage safely managed with no discharge or dumping in the drains, and sewage treatment, water bodies. So here comes our management and treatment and all that. So you have some managed safely. Management is also part of this. Any doubts in this? No. Okay, so let's proceed on to the next one. Match the following organizations with its responsibility concerning sewerage and sewage treatment. So we have different government and non-government organizations, and their responsibilities given as the option. So option A, Ministry of Housing and Urban Affairs, Government of India. So what do they manage? So let's go first one. Are they responsible for planning, funding, and coordinating drinking water and sanitation programs in rural areas? Or
No,
are they
ma'am.
no? Okay, or okay, then are they independent monitoring of other agencies, NGOs, and ULBs to ensure compliance of existing laws and rules? Is it option two? Or are they involved in planning programs or capacity building, micro level management on people on behalf of the government? Or do they formulate policies and provide technical assistance to the state and ULBs?
Ma'am, 4.
Okay, Partha says four. Anybody else? No, okay. So four is yes, yes, Subiksha.
One first, ma'am. Responsible for planning.
So they are responsible planning, funding, and coordinating drinking water and sanitary programs in rural areas. So yes, so this is a possibility. I understand this is a possibility you're saying, because they're responsible for planning, but sorry, I went to the answer. I'm so sorry. Yeah. So this is the problem with slideshow. You can immediately go to the answer. Sorry about that. Yeah. So this is one possibility, but we have a better option, which is there, which is this is definitely their role. That is so Ministry of Housing and Urban Affairs, it formulates policies and provide technical assistance to states. So this is at a central level, right? So central level, what is does is it's the central level plans the policies, and it gives technical assistance to states. And so what is ULB again? ULB?
Urban local body.
Correct, yeah. So urban local body. So you have state, and then at an urban level, you have the local bodies also. So this is definitely a function. Now this one, responsibility for planning, funding, and coordinating drinking water, this can be a state responsibility also, or it can even be an urban local body responsibility also, because it mainly talks about a specific region. For rural areas, it's a micro planning, it's not a macro planning. Whereas this is a macro planning, which mainly talks about the ministry at a central level. So this is for this Ministry of Urban Housing. Now ministry will delegate the duties to different small agencies. It can be state, urban local bodies, or even NGOs, in order to do all these micro level planning. So this comes under a bit of a, not too micro, but then not macro also. So let's see which is, so you have Ministry of Drinking Water and Sanitation. Yeah, so this fits in. Does this fit in correctly for your option one? Responsible for planning, funding, and coordinating drinking water and sanitation programs in rural areas. Does that fit better?
Yes, ma'am.
Yeah, so that fits better. So, uh, housing formulates policies for states and ULBs, but there's a separate ministry which takes care of drinking water and sanitation. So that comes over here. Correct. Now you have C, NGOs. What are they responsible for?
Third, ma'am. Third.
Third, NGOs are responsible for programs of capacity building, micro level management of people on behalf of the government. So yes, so you have it here in the question itself, on behalf of the government, which means it's not a government organization, but they do. So this I think you have this. So this is important. Keep a note of that. Yeah. So NGOs are important for capacity building. So it's very important to know that capacity building and micro level management of people, the ministry does not do that. So keep that in mind. I think in this assignment it would be useful. So the ministry does not take care of capacity building or micro level management. So yes, so correct. It is option 3. And now option D, you have regulators which are responsible. So regulators, what is your option which is left now? Yeah, so option 2, independent monitoring of other agencies, NGOs, and ULBs to ensure compliance of existing laws and requirements. So again, so it's there in the question. So they're mainly checking the compliance of existing laws and rules. So you're regulating something. So regulators check the compliance of laws and rules. So yeah, so that marks out to option A. Any doubts in this question?
No, ma'am.
Okay, very good. Thank you. So let's proceed on to the next question. What is the design period for a sewage treatment plant in years given by CPHEEO? Yes. So, any guesses for this? No. Okay. So before that, what is CPHEEO? So I think most in our lectures, most of the tables or standards which we have taken, we say that it's from CPHEO manual. We have taken it from. So CPHEO stands for Central. I'm not writing the whole thing. Public Health and Environmental Engineering Organization. So this body is responsible. So it's a part of the Ministry of Urban Development. So it's a small wing in the Ministry of Urban Development, and it mainly deals with all the matters related to water supply, sanitation, etc. So all the manuals, that is why all the manuals that we are seeing regarding water supply sanitation is from CPHEEO manuals. So in our references also, you might have noticed that most of the content we have taken it from CPHEO manual. So now we are talking about design period. So, okay, what is design period again? Let's have a quick recap. What is design period?
Like how much period of time it should be worked.
Yeah, very
Like
good.
when decision itself will be saying it. Ma'am.
Yes, very good. Yeah, so this we learned in our module 2, I think, where we discussed about design period. So it's mainly the duration for which the facility should last. So in this particular, at that time, we were mainly talking about water supply facility. So that's where we learned. So here again, now we are talking about sewage facility. So there we were designing reservoirs or underground tanks, or like how do we uh, take water from underground. So all those infrastructure we were underground wells, our aquifers, how long will they last? So all that we were learning, and then we were learning about overhead reservoirs, pumping stations. So all that we design periods. So we were thinking of if you're building a facility, how long should that last? So here again we are mainly talking about treatment plants, and for a treatment, so here we are talking about sewage treatment plant, but in the lecture we discussed about other things also, other sanitation facilities also, and we saw how, sorry, yeah, and we saw how long should the facility be designed for. So yeah, so that is design period. And in this lecture, this week 7 lecture, we learned about short term planning, medium term planning, and long term planning. Remember? So short term, approximately if it's like around for 5 years, that means it's a short term. The design period is short, or you're planning it for a short term. Then you have medium, which comes up to around 15 to 30, 15 years, around 15 years, it's medium. And if it's about like 30 years, around 30 years, then we call it medium. So these are very general numbers which I'm saying. Uh, I mean, this is a range just to give you a range of value. So around like 5 years you'll have short, then 15 years medium, and if it's around 20 to 30, not 20, 30 to 35 years, then you say it's a long term. So now, yes, coming back to the question, we are talking about sewage treatment plant. So yeah, so now based on this short term, long term, can you have any guesses on what this will be? So do we design it for a short term, medium term, or long term treatment plants?
Medium.
Medium term, so let's say 15.
Yes, ma'am.
Anybody else any difference of opinion? Okay, no. So yeah, so we design it for medium term because again, treatment plan it is a investment. You have multiple. So in our towards the end of our lectures, I think last two lectures we saw different types of treatment plans also, the different layers which are in last lecture I think. So we saw the different layers which are involved. So it's an investment. So designing it for a short term is not a feasible option because you're investing something for it. So if it gets worn out in within 5 years itself you'll have to again invest more on that. So you need it for some more. And again, investing it for a long term might also not be a good because there are certain elements or components which are there in it which might get worn out in a short term or a medium term. So you cannot keep the treatment. So you have to keep replacing it. So this is not something which is designed for a long term also. So a medium term is a good enough. So 15 is the right answer. So yeah, it could have been anywhere 10 or 20, but as per CPHEO manual, you say that 15 years is what we have. So let's see some of the other things. So yeah, so we have other elements which are part of the sewage treatment or sewage components. We have land acquisition. So this we learned. Land is something which needs to be a long-term investment because you cannot keep changing the land. You don't leave one land and you go to another land to build another treatment plant over there or when it's a sewage. So land acquisition, it's always done for a long term. Then sievers also laid for a long term, but non-conventional sievers that's laid for a short term because they might have come out of certain emergencies or certain specific requirement which is there. That's why they're non-conventional also. Or it's based on the reason. So you have it for a medium term. Then you're pumping mains, which are for long term. Pumping stations also long term. Machinery, but yeah, so machinery can get worn out. So it's for a medium term. Treatment plant is for a medium term. Disposal again for a long term. And utilization, so it can be for a medium case or based case specific, it can vary. So yeah, so these are the standards which are there. So based on the standards we usually design. Yeah. Any doubts? No? Okay, let's proceed to the next question. Question 7. Which of the following statements is or are true concerning the city sanitation plan? So multiple answers are correct. So first option A, it considers only long-term sewage project plans. B, it involves a determination of existing needs or demand or deficit. C, it involves the evaluation and monitoring of 100% sanitation status. D, it involves capacity building. So option A, is it correct? Option A, is it correct? City sanitation plan, does it involve only long-term sewage project plans?
No, ma'am.
What all does it involve then? We just discussed.
Uh,
We didn't. Yes, sir.
it is
Yes.
more focus towards channeling all the network, I guess,
Yes. Yes. It is. Yes.
instead
It
of
is focused on that. Uh, yes. So it involves both. So long term, yes, channeling all the network is a long term plan which is there. So it focuses on that also. And but you also have other short term or medium term plans which we saw before, like the previous one we saw. For instance, any treatment plan which is there for it's for a medium term or machinery or laying of sewers. It can be for a medium term also. So all these will also come. So these are the components for a sewerage component. So these will also come in your city sanitation plan. These are also involved in this. So it considers both long term, short term, and medium term. So this is clear in our next slide. We will see all the components of city sanitation plan. So it involves all even short term, medium term, and long term plan. So when you say that only long term plan, then that is a wrong answer. Now, B, it involves a determination of existing needs and demands are deficient. Is it correct?
Yes, ma'am.
Yes, it's correct. So I think that is what I think Gaurav was also trying to say. It looks at channelizing things. So you are understanding what is the existing needs or where is the demand there, what is deficient, and how do you channelize it towards it. So yes, it involves that. Yes. And option C, it involves the evaluation and monitoring of 100% sanitation status. Yes, no?
yes, ma'am.
Yes. So this is planning for it. Then you also have evaluation. That is also part of city sanitation plan. Now, option D, does it involve capacity building?
Yes, it do.
Yes, it does. So let's see. So capacity building we saw in the previous one. What is capacity building? The different organizations. So NGOs are in charge of capacity building and all that. So this is what is our city sanitation plan, which we learned. So this is from our Ministry of Urban Development report. So yes, so it involves all the aspects. So you have the operation and maintenance. So this is what we saw. Then you also have the implementation. So it implementation, management, all that. It also has the capacity building. Then yes, then it has the evaluation for 100% sanitation status. So it evaluates also. Then what was the other one? Yeah, existing needs to understand the existing needs, setting up technology, baseline, special approaches, settling up task force and implementing agency, meeting resolution, O&M. Oh, no, but it involves, maybe it's not, but it involves this one, understanding the existing needs and demand and deficit also. Yes. So, yeah, so now for wastewater management, all these are also given. So that is our next question. Let's come to that then. Was there any doubt in the previous question? No, okay. So let's go to the next question. Match the following wastewater management parameters with service level benchmarks. So these are again, so by service level benchmarks, we are mainly talking about the percentage of facility that, so for each parameter, how much percentage of that parameter needs to be there in order to, so it's a benchmark. So you say that if it, at least this much percentage should be there. The benchmarks have been set based on that. So let's go option by option. So this is directly from the manual. So there's nothing more to discuss. So we can guess and then go. So coverage of toilets, how much percentage? Any guesses?
100%.
Okay,
100.
so coverage of toilets 100%. Yes, we just saw it right now. Then extent of reuse and recycling of sewage, how much percentage? Extent and recycling of sewage, how much percentage?
Ma'am, I think 20.
Okay, okay. Recycling of sewage is not given much importance. Fine, let's see. Then redressal of customer complaints. Yeah, so it's
80, ma'am.
80
80.
percentage. Redressal of customer complaints, you say it's 80 percentage. Okay, correct. Then D, efficiency in collection, so 90 percentage. So this is what is there. So let's see. Yeah, so this is, we just saw it in the previous slide. So yeah, coverage of toilet 100 percentage. Then what else was there? Yeah, efficiency in redressal of customer complaint 80 percentage, efficiency in collection of sewage 90 percentage. Yeah, extend and reuse of recycling sewage 20 percentage. Yeah, so all this you need not memorize the whole thing, but I would say for examination point of view also, some important things like especially the 100 percentage ones. So there are so many 100 percentage that you can remember a bit because it might be important for your examination point of view also. So yeah, so this one works out to option D. So yeah, we just discussed this. So let's go to question 9. Which of the following statement is not an example of an on-site sanitation system? Firstly, what are the different sanitation systems and what is an on-site sanitation system? So we learned 3 types of sanitation systems. Can somebody give a quick recap of 3 types of sanitation systems? Anybody? Partha, I think you can do that.
Ma'am, leach pit, septic tank,
Yes.
and
C and D, I guess.
Yeah, so these are all types of sanitation systems. Sorry, these are all examples of sanitation systems like leach pit, soak pit, septic tank. These are all examples. I'm saying broadly, so here they've asked for an on-site. So I can say that one of the type of sanitation system is on-site sanitation system. Apart from that, 2 other sanitation types we learned. Anybody ringing any bells?
Decentralized.
Very good. Yes, so you have got decentralized, and then of course, if it's decentralized, then what's the other one?
Conservancy.
Conservancy, yes, we learned that also. Then you have the centralized system also. So conservancy, yeah, so we can say centralized system, decentralized system, and on-site system. So these are the 3 which are normally in practice right now. Or if you look at any city, mainly these will be there. And decentralized itself can be a combination of centralized and on-site. So it means there's a decentralization which is there. There's some, like if you have a city, then over here there is one STP or sewage treatment plant. So this region caters to, then there can be a central system which caters to all the region. And then some regions can have on-site sanitation systems also. So yeah, so these are the three which we learned. So again, by definition, centralized means there's a central facility and you're carrying out all the sewage to that central facility and the treatment is happening at the central facility. Decentralized is what we discussed right now. There can be small clusters and it can be along with a centralized facility and an on-site facility also. A mixed facility can also be called a decentralized facility. Then you have on-site, which means you're not transporting it anywhere, but on the site itself, you're treating it and you're removing the effluent out and then you're taking the sludge out. So there's some on-site treatment facility which is there. So we have been given four options and asked which of the following is an on-site sanitation system. So let's see. A, small bore sewer system. Is it an on-site sanitation system? Any guesses? We can just if you can guess. Yes, no. Yes, no. Nobody, no opinion. Okay, let's let's start from the last option. Septic tank. Is it an on-site sanitation system? Septic
Yes.
tank, yes, we should be knowing septic tank because in most of our houses there's a septic tank, right? In our residences, if you're so, I think yes. So, is there are there any architects here or planners there?
Ma'am, myself, I'm an
Yeah.
Ha, okay, very good. Yeah, so architects should be able to answer this. So when we are designing something, you always leave a space for the septic tank also, right? Because you need to, the residential waste directly goes into the septic tank, so you will have space for that also. So yeah, so septic tank is an on is it an on-site sanitation system? Yes, no? Yes.
Yes.
Yes. It is an on-site because in the building itself, so not building, within the site itself, it's going. So what we have learned also. So what happens in a septic tank? So it the effluent comes and then whatever solid it's allowed to settle down and then the effluent goes. So you have multiple, so there can be multiple chamber or it can be a single chamber one. If it's multiple chamber, it goes to multiple chambers and finally you separate out the sludge and the effluent or the liquid part and then you remove that out. So this liquid settles and it goes down. So it's an on-site sanitation. Then you have a soak pit. Is it an on-site system?
Yes.
Yes, somebody says yes. Okay, let's keep it as an. So, okay, so this is asked not an example. So, which means these are not the correct answer. Then you have a leach pit. Is it an on-site?
Yes, ma'am.
Okay, it
Yes,
is an.
ma'am.
We will come into the details of each more. So, this is not. So, then you're left with small bore system. So, the answer is small bore system. Small bore system is not an on-site sanitation system. It's so in small bore system you have something where you have the you collect it and then you transport it to a different location and then the treatment happens in a different location. So we'll see that in detail. So a small bore system collects and conveys the effluent from septic tanks and aquapribes for off-site treatment and disposal. So it's a combination. So you have a septic tank which is an on-site system, but from this the small bore system collects it and it conveys it to an off-site treatment and where it is disposed of. So this can also be there in most of the residences. It can be there. Then yeah, so it's just designed for conveying only the settled sewage, which allows a lower flow velocity. So you mainly take all the settled sewage, which is mostly water, which is transported out. And why its advantages is that it can reduce the cost in terms of excavation, slope, material treatment. So your septic tank now need not be of that much depth. Like your capacity of the septic tank can be reduced because you're taking half or some amount of sewage which is corrected and that is taken out for this offsite treatment. So that's one advantage, which is so you save in cost. So why again, it's a logical upgrade from the existing on-site sanitation system. That's what it's a combination or it's an upgrade from the sanitation system. And one more additional benefit is that it can allow new development. So you can, because this facility is there is new depth, so new development in fringe areas, and then you don't have any, you're not restricting the future development which is there, or you're not like your space or sullage treatment. So all this is not getting affected by that. So these are the advantages of small bore system. Now let's see. Okay, slide change. Yeah. So let's see the other types of systems which we saw. So this is an on-site system. So in leach system, what we have is that we have a storage and a digestion. So why we use it is what do you say? The treatment happens within the system itself, and it's called a leach pit because of the treatment by which you uh, or the sewage treatment that you're using inside the pit. So you use all the microbial treatment in order to do this. So what is important over here? So you have the water table, age, water, excreta, then you have your microbial condition which is there, temperature, soil, cleaning media. So all this is what is important over here. So it can be a wet pit or a dry pit. So if it's a wet pit, then you have the groundwater table above the bottom of the pit. If it's a dry pit, it's below the bottom of the pit. One sec, somebody wants to join. Yeah. So it can be the in the bottom of the pit. So now this one, okay. So for minimum period for effective pathogen destruction in a leach pit is 1.5 years, and because of this, every 1.5 to 3 years you will have to keep emptying the pit. So just keep this in mind. We might come across this later. So keep this in mind that so leach pit, the only problem is you will have to keep emptying this in around, you'll have to ensure that it's emptied in around 1.5 to 3 years, because the pathogen destruction happens in 1.5 years. So after that, you need to keep changing it because of the treatment which is there. So yeah, so that's a leach pit. Then yeah, so this is septic tank. So this is what we just, I gave a very rough idea. So here we have discussed in detail. So this is a plan view of that, and this is a sectional view of that. So you have your sewage which is stored over here, and it's sloped this way so that all the sludge can get accumulated over here from there, and then all the water can be or the effluent water can be taken out. So and then you can have line channels in order to remove this. So this is a channel. So you have the outlet which removes it off. So this is mainly used for individual homes or small communities. So this is a twin compartment system. There can be a single compartment system also. We cannot use it by large communities. Again, you'll need a large system, right? So in that cases, maybe sending it off or using other treatment facilities, sewage treatment facilities would be better. So yes, so this one, yeah, now we have the soak pit. So this also we discussed in detail in the lecture. So you have a pit like this where the inlet comes, and then you have also, so this is a semi-permeable membrane. So all the water or the effluent which is there, it dissolves onto this gravel or surrounding areas which is there, and you have the sludge or the solid or the concentrated elements over here inside. So sometimes it can be made with a brick chamber. So we learned it can be a honeycomb brick, which means you have bricks like this and this part is hollow. So you have bricks like this and then this part is hollow, which means it allows water to completely, or the effluent or to completely go outside. So yeah, so that's a soak pit. So yeah, so that's it. So we've discussed all the options. So all these are this one on-site treatment facilities. So let's go back. Let's see the leach pit, soak pit, septic tank. Yeah, all we discussed. So yeah, small bore pit is the answer for this. It's not an example of on-site sanitation system. Any doubts in this question? No? Okay, let's proceed on to the next question. So yeah, so question 10. The optimal pit emptying frequency of a leach pit is? Yes. All should be able to answer this now.
Option A, ma'am.
Option A, 1.5 to 3 years. So this is what we just discussed. Why? Because effective pathogen destruction happens in about 1.5 years. So within 1.5, so again, if the next tenure, one more 1.5 after 1 point, maximum after 3 years, like beyond 3 years, if you don't empty the pit, then it will become a problem. So a optimal pit emptying frequency is always 1.5 to 3 years. Okay, let's proceed on. So yeah, so this is, we just discussed this. So not going. Yes, question 11. Infiltration area required for infiltration of waste liquid in the leach pit is given by which of the following? Yeah, so this, I think some recollection. So option A, total flow in pit every hour divided by infiltration rate. Option B, total flow in a pit every day by infiltration rate. Option C, total flow in pit every hour divided by sludge accumulation rate. D, total flow in pit every hour divided by sludge accumulation rate. So we need to know what comes in the denominator, what comes in the numerator. Infiltration rate, so in the denominator, is it infiltration rate? Or so by sludge, what we are talking about is the concentrated uh, waste elements, and infiltration is the effluent or the water which is there along with it. It infiltrates outside. So infiltration area,
Option B, ma'am.
option B, total flow in pit every day divided by infiltration rate. Anybody else, any difference of opinion or any other answer? Okay, so this is the correct answer. Total flow in pit every day divided by infiltration rate. So again, why it's there? Because infiltration area required for infiltration means we're mainly, if you take for every hour, we will not get the correct estimates, because eventually throughout the day, if there's total infiltration, it gets accumulated, right? So if you're just taking it for one particular hour, it would be very less that you are having. So we need to take it for every day, what is there, and you're divided by the total infiltration rate. We don't take the sludge because it's the infiltration area which is there. So based on the total infiltration rate, if the infiltration rate is less, you need to increase the infiltration area so that it infiltrates outside and you have the concentrated sludge inside, so that the leach pit is more effective. So it's option B, total flow in the pit every day divided by infiltration rate. Any doubts in this question? Okay, let's proceed on to the next question. Question 12. What is the minimum number of dispersion trenches to be provided if the area required for the dispersion trench is 90 meters square? Consider the width of the dispersion trench is 1 meter. So this is a dispersion trench. So you have 1 meter width and area. So what is the minimum number of dispersion trenches? So how many dispersion trenches can we make if the area provide? So yeah, so depth is 1 meter and 90 meters square is the overall area of the dispersion trench that you have. So how many can we do? So yeah, how do we go about this question? So we learned in the standard the minimum length. So do you remember what is the minimum length of a dispersion trench? So it's 2 meters.
2 meters. 2 meters.
Yes, very good. Yeah. So dispersion trench, the minimum length, it has to be around 2 meters. And what is the maximum length? Maximum length was 30 meters.
15, ma'am.
No, 30 meters. Maximum length of the
Okay.
dispersion trench is 30 meters. Yeah, that was a good guess, but it's again double. It can be. So dispersion trench lies between minimum 2 meters and maximum 30 meters. So here the question asks, what is the minimum number of dispersion trenches which can be provided? So, and you know the total area. So you need, width is given. This is kind of given to mislead you, I would say, because it's already there. Width is already, you know the width, but in the overall area, it's already, so it's a volume. So to give the volume, this is given. But here we are mainly talking about, you have the length and you have the area which is given. So if you want to find the minimum number of dispersion trenches, would you divide 90 by 2 or would you divide 90 by 30?
90 by 30.
90 by 30. Very good. Yeah. So why? Because this is a since the minimum number is asked, you're taking the maximum length. So you're taking the maximum length and you're saying the minimum number of dispersion trenches that can be provided is 90 by 30. But if the question was what is the maximum number of dispersion trenches that can be provided, we will divide it by 2, because then you're taking the lowest, the minimum length, so that you can have you can maximize the dispersion trenches. So yeah, so the answer for this is 90 by 30, which works out to option C, 3.
3.
Yeah. Any doubts in this question? Okay, let's proceed on to the next question. Okay. So, yeah. Dash filter is a fixed bed biological reactor. Upflow aerobic filter, upflow anaerobic filter, Trickling filter, gravity filter. Any guesses? Okay, so firstly, what is a fixed bed biological?
Arabic, no? Upflow Arabic.
Upflow aerobic is what you're saying. Okay. Okay. Let's see that. But before that, tell me, what is a fixed bed biological reactor?
In presence of microorganisms, like wastewater will be treated.
Okay. So yeah, so I
It will
think
be a reactor kind of work.
yeah, you can split that into two. So there's a fixed bed here, then there's a biological reactor here. So what you explained was a biological reactor. So you have using microorganisms of some biological reaction, you are treating wastewater. So that is correct. But what do you mean by a fixed bed? Why is it important to have a fixed bed in this question?
Okay, ma'am. No, it's not upflow Arabic. No. It is. It will be moving in upflow Arabic. Sorry.
Okay, so what will it be then?
I think anaerobic because it will not have it will not have oxygen,
Correct.
and in stationary thing it will be happening.
Correct. Yeah. So the answer is upflow anaerobic filter. So you're right. Your logic is also absolutely right. So let's discuss that a bit. So by fixed bed, you mean that it's fixed, and in the biological reactor, you're planning that the biological reaction is going to happen in this particular region. Like it's not there. It leave alone the moving parts. Yes, nothing is moving. Apart from that, also, so sometimes it can be a combined. So somewhere, so the aerobic biological reaction can happen in this region, this region, this region. So it can happen anywhere. So even if that is the case, then it's not a fixed bed. In a fixed bed biological reactor, you know that there's a particular chamber, or you know that this particular region is designated for the biological reaction to happen. So that's why it's called a fixed bed biological reactor. So now you have upflow aerobic reaction, upflow anaerobic, trickling, and gravity filter. So let's see everything. So you have an upflow, so upflow anaerobic reactor, which is your option B. In this case, yeah, so in upflow aerobic, as rightly explained, you have some movement which is there, so it's ruled out. Now in upflow anaerobic, you have this region. So this is an example of upflow anaerobic filter, which is integrated with septic tank, and then you have a multi-chamber. So in both we will see. So in this one, you have a region which is fixed, where you have the biological reaction which is happening. Now here also you have a fixed bed where you have the biological, where it settles down, or the biological reaction is there, and the micro or the BOD removal happens in a fixed region, and you have certain other regions for the gases to emit and all that. So because of this, the upflow anaerobic filter is an example of a fixed bed biological reactor. But if you look at the other regions, other ones, which is so this is an example of a trickling filter. So what happens in a trickling filter is that you have your air which is going in. So consider this to be a cylinder, and it's sprayed out, the effluent, it's sprayed out, and then it's passing through a medium, and then it gets collected, and the filtered effluent comes out, and then there's clarified, and then it's treated, the treated water is going, and whatever sludge is there, which is remaining, it gets accumulated over here. So here you see there's no the biological treatment there. Firstly, it's so there is a media through which something's happening, but it's a filter media, so you're not having a biological treatment. Now leave alone, imagine if you had a biological treatment also, there is no fixed region, or there's no fixed bed where the biological treatment is happening. So both are ruled out. So the option which had fixed bed biological region, both are not happening in this. So this is not the answer. Then what were the other options which we had? Yeah, so your gravity filter also works in the same principle. So this we have learned. So you have multiple layers, and then because of gravity, you have it passes through. So last time we learned, we have for water supply mainly, we learned about rapid gravity filter, slow gravity filter, all this. So in sewage treatment also, when you're using, so there are multiple layers by which the water, the effluent passes, and the sludge is, so in a gravity filter also, at certain levels the sludge is removed, so you're not having a fixed bed biological reactor for that. So that is present only in an upflow anaerobic filter. Any doubts in this question?
No, ma'am.
Okay, let's proceed on to the next question. Question 14. Match the following sewage management systems with its functioning mechanism. So yeah, so we have different, so we have a packet septic tank with contact aeration type system, so these are a bit technical details, which I think in the lecture it's been explained very beautifully. So I mean, there's nothing more to explain from what is there in the lecture. So let's do this quickly. So packet septic tank with contact aeration type system, which one matches it the best, the functioning? Two aerobic digestion chamber
Third.
and yeah, third one. Somebody says third. Uses a fixed film plastic media with high specific area along with continuous diffusion of controlled air. Yes, so that is the packet septic tank aeration. So yes, correct answer. We have discussed this in our lecture. Now aqua privy, what does that work best? Yeah, what is its functioning? Two aerobic digestion chambers and filter chamber is involved in treatment. Is that correct? In aqua privy? Yes, no? Nobody. Okay. Then what? An anaerobic filter is employed and microbial growth on the media makes digestion possible. Aqua privy? Is that one? Is it two? No. Then last option, concentrated solution of caustic soda is used to sterilize and liquefy waste. So option 4, I think we can easily mask. In which one is a concentrated solution of caustic soda utilized to sterilize and
I
liquefy
think
waste?
chemical toilet.
Chemical toilet, yeah. So this is easy, like which we already know. I mean, it's in a chemical toilet which we use. So this we can mask. The other two, aqua
For
privy and
B, for B is it one, ma'am? The two
yeah.
aerobic
Very
digestion
good.
chambers.
Yeah, it is one. So in aqua privy, you have two an aerobic digestion chambers and a filter chamber is involved in the treatment. Yes, it is correct. So that's the whole principle of aqua privy also. So you have two aerobic digestion chambers and finally you take it to a filter chamber also. Correct. And yeah, so that leaves us with the multi-chamber anaerobic filter to be the one with an anaerobic filter. So yeah, so this by looking at the option itself, we will. So this is a multi-chamber anaerobic filter, and this is also here. Also, we are also talking about an anaerobic filter. Sorry, I erased it off, but yeah, here also we are talking about an anaerobic filter. An anaerobic filter is employed in microbial growth on the media, and through that the digestion is possible. So what does it work out to? Which option is that? A is
Option B.
4. Option D, right? Oh,
B.
sorry, B. Option B. Yeah, A is 3. Correct. Yeah, option B. Yes, very good. Any doubts in this question? Shall we proceed further?
Yes, ma'am.
Okay. So question 15. Which of the following statements is or are false for decentralized sewerage system? A, it is suitable for low density communities where STP capacity, by STP sewage treatment plant capacity is limited. B, it is suitable for low density communities and provides localized water reuse opportunities. C, it is suitable where STP capacity is limited but targeted treatment for specific sewage constituents are not possible. D, it is suitable where STP capacity can be expanded and targeted treatment for specific sewage constituents is possible. Okay, so we have been asked to find what is false and we have asked to find regarding decentralized sewage system. So again, we have centralized, decentralized and on-site. So here we are focusing on decentralized. So yes, so option 1, is it option A, is it true?
Yes, no.
It is suitable for low density communities and where STP capacity is limited. Yes, that's the whole purpose. Like we discussed. So decentralized, you will have small capacity, and also where some on-site facility is also not there. So yes, option A is the correct answer, which means it is not the answer for this because you've been asked to mark what is false. Option B, it is suitable for low density communities and provides localized water reused opportunities. True, false?
I think it
True.
false.
It's true.
Okay, difference of opinion. So somebody who said it's true, okay, somebody said it's false. Why is it false? What is wrong in the statement?
Ma'am, I think it won't. Water reuse and reuse opportunity is not done in decentralized, I guess. I'm not
Okay.
sure about it.
Okay. So firstly, decentralized, again, it is decentralized, agreed. But what is it essentially doing? It's a sewage treatment plant, right? It's a decentralized sewage treatment plant. And what does a treatment plant does? It takes out the effluent, it then you have a treatment facility, and after treating it, you're reusing the water. So what a treatment plant does is you're removing the sludge and you're removing the effluent out of it, and the effluent undergoes, by effluent I mean the liquid waste. So the effluent undergoes treatment, and that treated water can be reused. So that is the whole concept of a sewage treatment plant. So yes, so if it is a decentralized facility, it provides local reuse opportunities also because it's decentralized. Otherwise, it's a centralized facility, so it has to go to the central sewage treatment plant, and then the water gets treated from there, and then it comes out. So centrally the water has to be again pumped to different regions. But because it's decentralized, we have the option for a localized water reuse. So this answer is correct, which means for this particular question it's not the answer. So option C, is it suitable where STP capacity is limited? Is it the right answer?
True, ma'am. True.
True, ma'am.
Okay, so option C has two parts. It is suitable where STP capacity is limited, but targeted treatment for specific sewage constituents is not possible. So is this okay? So first part is true. Second part, is it true? Targeted
Yes,
treatment.
ma'am. We cannot do alternatives.
It's true. You're saying targeted treatment for specific sewage components is not possible.
It is
Yes, ma'am.
possible.
Okay. Partha, why is it not possible?
It is for small community, so they won't go for what is it, another treatment plant or another set of process.
Yeah, so but the point is, okay, so we need to get this clear. So you have a centralized facility, which means if I have a region, I have a centralized facility, which means everything is coming, or the sewage is coming to the centralized facility. It is getting treated and it is pumped back. So all the treatment, whatever needs to be done, so whatever the specific sewage constituents, whatever treatment, specific treatment which has to be done, is done at a centralized facility. Now, a decentralized facility is nothing less than a centralized facility. It has all the opportunities of a centralized facility, but the only difference is that if you have a region, you have a small decentralized facility where everything comes. And it can be there can be another centralized facility also along with it, which caters to a larger region. But it just means that you're doing something at a local level. Now, if you want to make it too local, it is an on-site facility where in an on-site facility, yes, targeting certain treatment facility might be limited because it's for a very, very specific small. For instance, if you have a septic tank, then you're talking about a small like even then you're talking about a community of about 200 people or 300 people. So it can be for residences, even for apartments or small housing complexes. You can have a septic tank facility for that small community. So by decentralized, what we're talking about is not that small. It's not as small as as an on-site facility that we're talking about. It's a decentralized facility, which means it's catering to a bit more larger region. So there also, all the facilities that you're doing in a centralized, or most of the facilities that you're doing in a centralized facility, must be possible in a decentralized facility. So when you say that targeted treatment for specific sewage components is not possible, it's a wrong statement, because then you will opt for a centralized facility because you need to have treatment. It is important. So even in a septic tank, we saw that there can be a mix, like the bore system, where you transport, small bore system where you transport it to an offsite place and where you treat it. So there, the treatment facility, you're going for multiple options in order to treat the specific sewage components. So here in a decentralized system, you should have the facility for targeted treatment of specific components. Otherwise, it won't serve its purpose, because eventually if you cannot treat the water and if you cannot reuse and recycle the water, then the whole STP is not functioning, right? The whole concept or the whole idea in which it was installed is not working. So this statement, the second part of the statement, is actually false, that it should have a facility, or even in a decentralized system, it should have a facility in order to treat the specific sewage component. So this is wrong, which means this can be a possible right answer. Now option D. Is it suitable where STP capacity can be expanded and targeted treatment of specific components is possible? Yes or
It's
no?
false. False.
It's false. Okay. Why do you say it's false?
Because STP capacity is limited in case of decentralized sewerage system.
Decentralized.
Cannot. There is no possibility of expansion.
Oh, okay. Okay. So,
The STP capacity is limited. The first half of the
okay, I understand your point, but no, STP capacity, it's not limited in a, so that's what, decentralized, no, it's not limited in a limited as in, so you have a community, it's serving that particular community. Now, so by decentralized system, what we mean is it can be a mix of different elements, right? So, as we discussed, so if you can have a centralized facility, then you can have a small local facility over here. You can also have on-site facilities in a decent, so this whole thing constitute a decentralized system where you have multiple components which are there. So this small one, so if you look at a micro scale, this might look like a centralized facility to only that particular region. So the whole idea of decentralized is that if the capacity, so I understand your point where you're saying that the STP capacity is limited. Yes, you're partially right. For that particular region, when you're designing an STP capacity, that might be limited. So if the density increases, yes, it might be limited. But the beauty of decentralized facility is that you can always have another decentralized facility. So the whole system still becomes so you are having another STP which caters to this. So it's another, so it all comes under the decentralized facility. So if you feel that the capacity is limited, you can always expand it by creating another facility. But in a centralized system, that's not possible because it's central. So that is where expansion is actually limited because everything is centrally controlled. So if the capacity, if the STP capacity is reached, then you will have to design another central capacity, so centralized system to cater to everything. So the design period must be for a longer duration and it becomes redundant if it's for a very long duration. If the density of people increases or if there's a sudden increase in the effluent which is there, then it becomes redundant and you'll have to build another system. Why? Because in a centralized system, a decentralized system cannot be there. Like you, if it's called a centralized system, then you cannot have another decentralized facility along with it. But a decentralized system encompasses all these. So you can have multiple small decentralized systems. You can also have on-site systems also. So in a decentralized system, the STP capacity can be expanded. Okay, is that clear?
Yes.
Yeah. So yeah, second part, yeah, targeted. This is what we were explaining in the previous one. So yeah, so this is correct, which means this is not the correct option. So option D is the correct answer. Okay, any doubts in this question? No, that was an interesting discussion. I really liked your point, which it's a very logical thought which you had, but yeah, so that is the catch over here. I think we sometimes confuse when we talk about decentralized, we might think that it means that it's only for that particular system. No, it means you can have more. The whole idea of decentralization is that you can have multiple small systems sprouting out based on the requirements. Okay, so yeah, so this is what we discussed. So yeah, so decentralized system. These are suitable for small and low density communities for isolated areas and where alternative systems are not feasible. And yeah, so this is a centralized system. So this is what I was explaining. So which means there's only one STP. But a decentralized system can have one STP1, STP2. It can also have on-site systems. And on top of it, you want to have a centralized. So this is more or less like a centralized system because it's covering to a lot of a large region. But for this entire region, this becomes a decentralized system. If you look at only this region, you can say that yes, it's a centralized system. You can say, but this is a decentralized system. Now, and then you also have some on-site systems also. So yeah, so it allows localized water reuse opportunities, targeted treatment of specific components. That's also there. Now, yeah, so for a conventional sewage system, the STP capacity is limited and expansion is not possible. So this creates a problem. So that is why this is an improvement over existing on-site sewage system, and it's and it's a cheaper alternative. So I think when we see this slide, we might misunderstand it by thinking that decentralized system has limited STP capacity. No, it means that conventional sewage system has limited STP capacity, and the expansion is not possible. Okay. Okay, so very good. So that's it. So that's all for today's discussion. So I think we have half an hour more. So if you have any doubts regarding any of the previous week's assignment or this week's assignments or anything till week 7, you can ask now. No doubts?
No doubts, ma'am.
Okay. That is good. Fine. So yeah, so I think exam pattern, I think I've already been saying in different classes. So it will be very similar to the assignment questions, multiple option questions, and it won't be very difficult. So I hope all of you have registered for the exam.
Yes, ma'am.
Okay,
Yes.
Yes, ma'am.
good, very good. Yeah, so if that's the case, then we can wind up for today. Yeah, so thank you all for joining. Have a good night. I'll be there till 9 o'clock. If you have any doubts, you can always log in back and ask also. No problem. If nothing's there, yeah, so have a good evening, nice dinner, and good night.
Thank you, ma'am.
Thank you, ma'am.